Okay, welcome back to the next Unit 6 video. Again, we're going to do some more naming. However, this is going to be a little bit different because it's with acids instead. So first, let's figure out what is an acid and how are you going to identify it. Well, an acid is something that's going to begin with an H. Okay, this results from an H plus cation combining with an anion. And how we figure out the name is by looking at the anion, since everything has an H at the beginning. So, what if this anion ends in IDE? Okay, if it ends in IDE, that means that we have an H bonded to just one other nonmetal. Okay, so it's going to be H plus one other element. What we do is we have a base for the name. Each acid that begins with an H and has one other element is going to be named hydro something ic acid. Okay, so what we're going to do is take the stem of the anion name and plug it into that formula. So let's look at an example here. If I have HCl, ignore this H, okay, we need to find out what the anion's name is. This is just chlorine, okay, but remember chlorine, when it's bonded to something else or as an ion, its name is actually chloride. Alright, so what we do here is we take off that IDE ending and use this part as the stem of the name and plug it into this formula. So this becomes hydro, then chlor, which is our stem, then you add ic acid, so ic acid, hydrochloric acid. Next, we have, what if the anion ends in ATE? You're going to know it's ATE because it begins with an H, and the polyatomic ion ends in ATE. Okay, so this is going to be noticeable because there's an H with a polyatomic ion next to it. So the formula for this name is you have the stem and add ic acid. We take the stem of the anion again and add ic acid to the ending. So if I had H2SO4, ignore this H and find out what SO4 what's its name. So we have here, if you look on the polyatomic ion chart, this is called sulfate. Okay? If you have that ATE ending, you want to get rid of that and use the stem of this name and add ic acid. Now, since sulfic acid kind of sounds weird, this becomes sulfuric acid. And lastly, if the anion ends in ITE, that's actually going to be another one where there's an H to a polyatomic ion. However, the polyatomic ion ends in ITE instead of ATE. So the base for this name has an OUS acid at the end. So we take the stem of the anion and add OUS acid. So if I had H2SO3, you ignore this H and you look up what SO3 is. If you look on your polyatomic ion chart, the name of this is sulfite. Okay? We take off that ending and the stem is SULF. Okay? Now, since sulfus acid kind of sounds weird, just like sulfic acid, we add the UR back in the name. So this becomes sulfurous acid. Okay? So let's move on and do some practice here. So first, if we're given a formula, we need to figure out the name. So we're going to do something similar to what we just did. HNO3, I ignore that H because they all have H in them. I need to find out what NO3 is, okay? NO3 is called nitrate, all right? And if you look back at your chart and your notes, if it ends in ATE, we're going to add ic acid. Okay, so I need to use the stem of this name and add ic acid. So the stem of this name, if I took off the ITE, was NITR. So NITR. Then I add ic acid. So nitric acid. Okay, next we have an H and an F. Ignore the H, and you see we just have fluoride here. Okay. A good way to identify this is if there's just an H plus one other element like you have here, that's when you're going to use the IDE ending, okay? So that's fluoride, fluorine bonded, or as an ion, is called fluoride. What I need to do is take off that IDE and figure out what the base for the name is. If it ends in IDE, the base for the name is hydro something ic acid. Okay? So since I took off this IDE right here, the stem is fluor, so this becomes hydro stem, which is fluor, and then I add ic acid. So this is hydrofluoric acid. All right, lastly we have H3PO3. Ignore that H again. We know that this is H with a polyatomic ion. We need to figure out the name of this polyatomic ion from your chart. So this is called phosphite. Okay, so if it ends in ITE, if you look back at that chart, you take the stem of the name and add OUS, acid. Okay, so the stem of this name is right here. I take off that ITE, and this becomes phosphorus acid. All right, now let's go backwards. So if I'm giving you the name, you've got to figure out the formula. So how are we going to do this? So if I give you nitrous acid, I know OUS acid meant that it ended in ITE. Okay, so if you take off that right there and you add ITE to the stem of this, the anion name is nitrite. Okay, now nitrite is a polyatomic ion. It's NO2 with a -1 charge. So what we have to do, since every acid has an H in the beginning, I'm going to crisscross this formula with an H plus ion. So if I have H plus, remember the plus goes in the front part, the first part of the name, and I have NO2 with a -1 charge, I take these numbers, not the charges, and make them subscripts for the opposite element. So if there's one H, I just write H, and then this tells me I have one NO2, so I don't need to put it in parentheses. My formula is HNO2. Okay? Next we have hydroic acid, hydrobromic acid. So the base of this name was hydroic acid. That means that the ending was IDE. Okay, so I have to take off this part, and this part, and use this and add IDE to find the anion name. So this is bromide. Now remember, if it's an IDE ending, it's just one element with its charge. So bromine, as an ion, has a -1 charge because it comes from group 17. What I need to do to find the formula is combine it with an H plus 1. So I take these numbers, not the positive and negative, and make them subscripts for the opposite element. So there's one H and there's one Br. So your final formula is HBr. Okay, lastly we have acetic acid. So if I have acetic acid, the base of this name was ic acid. Ic acid means the anion ending was ATE. Okay, so here's the stem of the anion. So we have acetate. Added ATE back on because it was ic acid. Acetate, if you look at your polyatomic ion chart, its formula is C2H3O2, and it has a -1 charge. What I need to do is combine this with an H plus 1 and take the numbers, not the positive and negative, and make them subscripts for the opposite element. So this becomes H, there's just one of those, C2H3O2. And there is your final formula for acetic acid.